Hi guys, so I just wanted to show you the demo I did in class. It was not much, but here you have what it's called the toroid. You see, there is no connection. You have a coil on one side, and you have a coil on the other side. I don't know if you can see. Okay, and that was the experiment in miniature that Michael Faraday did, except that he didn't have like that kind of insulation. They had fabric instead. But here you have like a soft iron, so it's a toroid, which means if you energize, for example, this wire here, if I connect that to a power supply, if it's DC, I'm going to expand the magnetic field, but the magnetic field will be trapped inside that donut, right? Nothing will happen on the other side. See, I have the other side here, I have more loop on that side than on this side. So nothing will happen here. However, if instead of having DC, I have AC, the magnetic field here will expand and then collapse, and it will flow in one direction, it will flow in the other direction. So it's going to induce a voltage on the other side, induce a current on the other side in the other circuit, even though there is no connection between these two circuits. You see, they are not connected to each other. So it's just a coil on one side and a coil on the other side. So that's the idea of a transformer. So it means if I have AC here, let's say I have 10 volt AC, that has to be alternating voltage. On the other side, if you have 10 times more loops, I'm going to have 100 volt AC. So that's going to be a step up transformer. Of course, there is a price to pay because energy has to be conserved. So if you have 10 times more voltage, you need to have 10 times less current. But at the time, there was no AC at the time of Faraday. But what he was able to show, and it took like 10 years. Okay? It was not 10 years between the Oersted experiment and his experiment. So that was his experiment here that I'm showing you. But of course, it's in a miniature scale. Okay, so here I have a battery connected. I didn't turn on the switch. I didn't close the switch yet, so no current is flowing. And here I have just my multimeter. So of course he had a different way to do it. He didn't have digital multimeter at the time. But you see here I can detect voltage. You have to be careful to look. I hope you can see with the camera. So nothing is happening here. Almost nothing. Okay, there is nothing here. And just as he closed the switch, he saw the jump in voltage or the jump in current, but only when he closed the switch and then nothing. And when he opened the switch, again, he saw the jump in current because the electricity was flowing. So the magnetic field was expanding. When it was expanding, it's changing in this coil here. So it's induced a current. As soon as the magnetic field is done expanding, nothing happened. Okay. So I'm gonna do it. I'm gonna close. You should see that it's gonna change a little bit. I don't know if there is a glare here. Okay. I'm closing it. Boom. Do you see how it changed? I open it. So closing it again. You see? Very little, but it's there. So if I want to detect also current, you're gonna see the induced current just as I'm closing. Okay. The glare, closing, poof, is jump. Do you see? It's up. It's very small because I don't have many loops. But you see how as I close or as I open, you have a jump. Okay, so that was the experiment. But of course, this one is a miniature, so just for you to get the idea, because I don't have many turn. Usually you have a coil with many turn. Yeah, I don't have much turn. It's just to show you how it works. Okay. But you see there is no connection between them. If I have AC here, I'm gonna induce a voltage or a current. So here I have, here, I don't know if you can see, I have a real transformer. That, I mean, not that the other one is not real, but that's the one you use. I got this one in the Radio Shack. So back then, when it was still open. And that's the transformer you use, for example, in computer, the big computer. So it's turning here 120-volt AC into either 6-volt AC or 12-volt AC. So you have the choice between 12-volt between these two wires, or 12-volt, and it's AC. It's all written here, and it's also limiting the amount of current. Okay, so that's nice here. It's that I cannot have more than 450 milliamps. Now, I don't know if you can see on the other side, you see those two coils here. Okay, you have one coil on one side and the other coil on the other side. I didn't plug. So here what I did is that I connect that to, not to do at home, of course, connect that to a wire. I'll show you. See, it's a plug. I connect the extensions here on that side. So here I'm going to have 120-volt AC. And I'm going to show you that with this voltmeter, I'm going to get 12-volt AC or 6-volt AC. So I'm going to plug, see what's happening. So it's plugged. I have to be careful on that side not to touch. And here I have my voltmeter. I'm going to put that AC. So this is AC. Nothing. And I'm going to connect between the black here and the yellow. I don't know if you can see, but I'm reading about 6.6 volt AC. See, the knob here is in AC. So that's the RMS. It means that I get a sine wave, okay? And the maximum will be about at 10 volt, okay? Because it's going to be 6 volt times 1.44. If I measure between the two yellow, it should be about 12 volt. See, 13.7 AC, right? So the maximum is about 20 volt AC. I should not touch anything, of course. What I can try to do is see if I can, with this AC, maybe I can use my transformer here to see if I get something on the other side. So again, this is a toroid. You see there is no connection between the wire. So I'm going to connect that to here. Wait, I didn't try that before. Okay, so let's try it. Just 6-volt AC on one side. There is no connect. Ooh, you see. Got to be careful. Not too long. Ooh, because it's getting very hot. Let's see if I get something on the other side. I think it's getting very hot. Okay. I'm not getting anything. I'm going to tell you why. It's because I'm draining so much current from here that it shut down. Remember, we cannot have more than 450 milliampere. Okay, so that's why that experiment didn't work. It doesn't mean that physics doesn't work, but I fail to show you that how it works. I didn't fail because I showed you before, but the thing is this one has a 450 milliamps maximum current, right? However, what I can do to convince you is that I have a mini oscilloscope. So it's a very small oscilloscope. I'm gonna turn it on. Is it on? On? Okay, and I'm gonna connect it to the transformer. And I want to show you, the only thing I want to show you is that I get a sine wave. I didn't calibrated it right, so you won't see the value of the 6 volt, but I already show you that. I want to show you that I get a sine wave, and I want to show you the frequency. So here I'm connecting here. So it's just an oscilloscope. It's just like a voltmeter here. And what you see here is a sine wave. And if you can see the sine wave, and what you see is that the frequency is about 60 hertz. Can you see the sine wave? So, okay, it's very small, but I hope you see the sine wave. So that transformer turned a sine wave with 120 volt AC RMS into a sine wave, same frequency, 60 hertz, and the RMS is 6, okay? The reason it didn't work with this tiny transformer is because that is very smart. They don't want you to electrocute yourself like I almost did. There is a maximum current of 450 milliamps. So I hope it was helpful.